Hello, everybody. I'm getting better at that. How are we doing, everybody? I'm going to give you a super quick video that is as a reminder of how we go about adding fractions that have different denominators. And I'm going to try really hard to keep this short. So if I'm going too fast, I apologize. And please come and see me in office hours for more detailed explanations. But here is an example of the kind of problem we're working on today. We've got 3/5 plus 1/3. Now I can't add 3/5 to 1/3 because fifths and thirds are not the same. Remember the invisible box, right? You can't add or subtract anything unless it's the same. These are fifths, these are thirds. I got to change their name to something that is the same of both. To do that, I'm going to rewrite them as another fraction. I'm going to ask myself, what are the common multiples of 5 and 3? Now, if you're not sure what the common multiples are, we can always go over here and list our multiples. If I come over here and do 5, I can do 5, then 10, then 15, then 20, then 25. Those are all multiples of 5. And if I do the same for 3, 6, 9, 12, I had to think, 15, 18, 21. These are all multiples of 3. And I'm going to look and see which of these is the smallest number that's on both lists. Well, look, there's a 15 here, and there's a 15 here. And there's no number smaller that is on both lists. So that means 15 is a common multiple of both 5 and 3. So I'm going to change their name to something that is a 15 down here. Right? Now, if you remember, in order to do that, we're going to find an equivalent fraction by multiplying, which means we have to multiply by something to make that equal to 15 on the bottom, right? So what can I multiply 5 by to get 15? Well, 3 works, doesn't it? So if we multiply 5/3 by a 1 made out of 3s, it's still a 1. It's going to be the same. It's just going to look different. 5 times 3 is 15. 3 times 3 is 9. So that means 9/15 is the same as 3/5, right? Now we need to do the same thing for 1/3. I'm going to take 1/3 times what is going to be equal, give me an equivalent fraction with a 15 down here in the denominator. Well, let's see. 3 times what is 15? Well, 5 works there, doesn't it? So if I multiply 1/3 by 1 made out of 5s, I'm going to get 3 times 5 is 15, 1 times 5 is 5. So this is going to be 5/15. Now they're both 15ths, they're the same. I can go ahead and add them up. I can say 9/15 plus 5/15. That's going to be equal to 9 plus 5 is 14/15. Now, if you remember, you don't have to simplify in 5th grade, but you will next year, so we are going to talk about it. 14/15. Is there anything that can divide both 14 and 15 evenly by? Well, I can divide 14 by 7 and 2, but neither 2 nor 7 goes into 15, does it? I can divide 15 by 5 or 3, but neither of those would divide evenly into 14. So I know that this is simplified. That's the more beautiful answer, 14/15. Okay? Now if we go ahead and look at another one, another example of something that you're going to see today in today's work is something like this. 1/4 plus 3/5 plus 7/10. Okay? That's a 10. Now, I have 3 different pieces here. I need to find a common multiple of all 3 of these things. And I'm going to come down here and rewrite these as equivalent fractions that all have the same denominator. If I'm not sure what my common multiple is, I can always write out my multiples. The multiples of 4 would be 8, 4, 8, 12, 16, 20, 24. If I do the multiples of 5, I get 5, 10, 15, 20, 25. And the multiples of 10 would be 10, 20, 30, 40, right? So, what number is on all of these lists? Well, 10's on these, but it's not up here, is it? What else do we see? Hey, wait a minute, look at this. 20 is on all three of those lists. So that means 20 is a common multiple of both of all 4, 5, and 10, right? Now I know my common multiples. Now I need to figure out 1/4 times what is going to be equal to a new equivalent fraction with a 20 on the bottom. So what times 4 is equal to 20? That's just 5. 4 times 5 is 20. So 1 times 5 is going to be 5. And that means 5/20 is the same as 1/4. Let's do the same thing for 3/5. We've got 3/5 times what is going to give me an equivalent fraction with a 20 in the bottom. 5 times what is 20? Well, that's 4, isn't it? 4 times 5 is 20. So if I multiply by a 4/4, I'm going to get 3 times 4 is 12. So 12/20 is the same as 3/5, right? One more to go. We need to do the same thing for 7/10. 7/10 times what is going to be equal to an equivalent fraction with a 20 on the bottom? Well, 10 times 2 is 20, so 7/10 times 2 halves is going to be equal to 14/20. Now I've got 3 denominators that are the same. They all are the same, being called the same thing, right? We took Coke, Pepsi, and I don't know, Fanta Orange, and we've renamed them all as sodas, right? They're all 20ths. Now I can just add them up. 5 plus 12 plus 14. Well, let's see. 12, 14, and 5. That's going to give me 5 and 4 is 9, 10, 11. I get 31/20. Now that is an answer, but it's a little awkward, isn't it? That's one of those top-heavy improper fractions. So what we're going to need to do is come down here and simplify it. 31/20. If I take 20/20 out of that, here, I'll come over here and do it. 31/20. If I take 20/20 out of that, what does that leave over here? 31 minus 20, that's going to be 11/20, isn't it? Because 20/20 and 11/20 is 31/20. So that means this 20/20, that's just 1, isn't it? So that means 31/20 is the same as 1 and 11/20. And that, my friends, is the more beautiful answer. But 31/20 isn't wrong. That's still a correct answer. But this is a more beautiful answer. That's not an 11. I just made a mark there, right? That is the more beautiful answer. Okay, I promise I'd keep it short, so I'm going to stop there. If you've got any more questions, come see me at Google Hangouts, and I will answer them then. All right, thanks, guys.